Let's look at how we can understand how to tune and tweak and maybe even troubleshoot Kafka a little bit here. So again, Kafka, it's a distributed and partitioned and replicated log service. It was developed by LinkedIn. It was open sourced in 2011. Basically what Kafka is, it's a massively scalable pub-sub messaging queue that's architected as a distributed transaction log. And it was created to provide a unified platform for handling all the real-time data feeds that a large company might have. Now, there are a few key differences between Kafka and other queuing systems like RabbitMQ or ActiveMQ or WebLogic JMS or WebSphere JMS. As I mentioned before, Kafka is fundamentally a replicated log service. It does not use AMQP. It doesn't use any other pre-existing protocol for communication. Instead, what Kafka uses is a custom binary TCP-based protocol. Kafka is very fast. Even in a small cluster, it's very fast. Kafka has strong ordering semantics and durability guarantees. Kafka is designed by many organizations. Many organizations contributed to the architecture and design of Kafka. It's still used by many organizations. Obviously LinkedIn, but Pinterest, Twitter, Datadog, tons of them. So the latest release of Kafka has even more new features. But before we dive in, it's important to really understand the general architecture of a Kafka deployment. And I realize that this is potentially a review, but I like to go over this anyway so that we can have context about where each of these settings belong. Every deployment in Kafka consists of all of the components that you see on the slide, on your screen. That's the landscape for Kafka. Kafka brokers, they act as intermediaries between producer applications, which send data in the form of messages. In the Kafka universe, we call them records, and consumer applications that receive those messages. A producer will push messages to Kafka brokers in batches, so it can minimize the network overhead by reducing the number of requests. Brokers are going to store the messages for consumers to pull at their own rate. Messages, they consist of metadata describing the message payload, and maybe even some other arbitrary headers, at least as a version, I think like 0.11. Messages in Kafka, they're written to the log in the order that they were received by the broker. And this log, this commit log, it's immutable, with read as the only permitted operation. Kafka is then going to organize these messages into topics, which store related messages, and consumers are going to subscribe to the topics that they need to. And the topics are themselves. The topics are divided into partitions, and the partitions are assigned to brokers. So the topics are therefore going to enforce a sharding of data on the broker level. The greater the number of partitions, the more concurrent consumers a topic can support, and hence greater parallelism. You can drain these queues faster because you're consuming these records in a parallel fashion. So when we're setting up Kafka for the first time, you should be careful to both allocate a sufficient number of partitions per topic and make sure that you fairly divide the partitions amongst your brokers. Doing this when you're first deploying Kafka can minimize the growing pains down the road. So there's a lot of resources around that. Confluent has a lot of good resources around that. So Kafka's replication feature, it provides high availability by optionally persisting each partition in multiple brokers. Gives you replication. In a replicated partition, Kafka will write messages to only one replica. Okay? The partition leader. The partition leader is a primary replica. It's a primary partition that you're writing to. The other replicas, they're known as followers. And these followers, they fetch copies of the messages directly from the leader. And consumers may read from either the partition leader or from a follower. And this is as of Kafka version 2.4. In older versions, the consumers would only read from the partition leader. That's no longer true as of 2.4. Now, this architecture, it distributes the request load across a fleet of replicas. In addition to that, any follower is eligible to serve as the partition leader if and only if the current leader goes offline. And this is provided this follower is recognized as an in-sync replica, an ISR. And Kafka considers a follower to be in sync if it has successfully fetched and acknowledged every message that's sent to the partition leader. If the leader goes offline, Kafka elects a new leader from the set of in-sync replicas, ISRs. However, if the broker is configured to allow an unclean leader election, in other words, it's unclean leader election .enable value is set to true, it may elect a leader that is not in sync. And last but not least, no Kafka deployment is complete without Zookeeper. Now this is going to change in the future, but as of the time of this video, Zookeeper is a required dependency for Kafka. And Zookeeper is the glue that holds it all together. And Zookeeper is responsible for electing a controller, a Kafka broker that manages partition leaders, for recording cluster membership, for maintaining topic configuration, applying any quotas that you set to limit the throughput of producers and consumers. It's very important. So let's look at monitoring Kafka, right? What are some of the statistics, right? What are some of the things that you're going to want to keep your eye on with respect to Kafka? And Kafka exposes monitoring statistics using what's called Yammer, or Yammer metrics, Y-A-M-M-E-R. In Yammer metrics, it's a protocol that exposes 6 types of metrics. It exposes gauges and counters and meters and histograms and timers and health checks. And what we're going to do here is I'm going to show you how to monitor the metrics that are exposed by Kafka from the server side. Later, I'm going to show you how to monitor the key metrics from the producer and the consumer-related metrics. So to do this, all that you need really is any Kafka broker. You need that up and running. And you would need to set the JMX port. You can do that from the same directory that you're going to run the broker. And you'd use the command that you see on your screen. So take a look at the screen. I would ask you to execute these commands to start the broker with an idea that we're going to monitor with JConsole. Okay. Execute those commands. This is going to open a port, a JMX port, and then we can use JConsole to interrogate the JMX mbeans. Once you do that, I want you to go to the mbeans tab. And let's discuss how this works, right? How all of this works. The JConsole application, if you're a Java developer, I'm positive that you're familiar with JConsole, but that JConsole application, it connects to the JMX port that's exposed by Kafka. And using JConsole, all the metrics can be read. The details of the metrics exposed by Kafka with the mbean object name are going to be things like messages in per second. And this is going to give you the number of messages inserted in Kafka per second, obviously. It has the attribute values given as counts. Okay? Minute rate, 5-minute rate, 15-minute rate, and a mean rate. We also have under-replicated partitions that you can see. And this is going to specify the number of partitions for the number of replica criteria that's not met. So if this value is greater than 0, it means that the cluster has issues replicating the partition as planned. There's also active controller count, which gives the number of active Kafka controllers for re-election. There's leader election rate and time in milliseconds, which gives the value of the rate at which the leader election takes place. And also the latencies involved in that process. It gives latencies as percentiles, 50, 75, 95, 98, 99, and 99.9. And it also gives the time taken for leader election as minute rate, 5-minute rate, 15-minute rate, etc. And it's also going to give the count. We have unclean leader elections per second, which is a statistic of the unclean leader elections. And it can give these values as a mean, right? 1-minute rate, 5-minute rate, 15-minute rate, etc. It also gives a count. We have the partition count, and this gives the total number of partitions in that particular Kafka node. There's the leader count, which gives the total number of leader partitions in that particular Kafka node. There's ISR shrinks per second, which specifies the rate at which in-sync replicas shrink. It can give these values as a mean, okay? 5-minute, 15-minute rate, and so on. It also gives a count of events. ISR expands per second, which specifies the rate at which in-sync replicas expand. It can give these values as a mean rate, 5 minutes, 15 minutes, so on, and give you the number of events. There's max lag, okay, max lag for the replica. And this is going to specify the maximum lag between the leader and the replicas. So I want you to use the command that you see on the screen, and I'd ask you to monitor the producer. Now keep in mind that we're going to go over all of these later, but for now, this is how you could monitor the producer. And you'll see things like the producer request rate and time MS. I was covering brokers before, now I'm looking at the MBeans for producers. The producer request rate and time MS, this gives the value for the rate of producer requests taking place as the latencies involved. It gives latencies as a percentile and gives the time to produce the data as a mean, right, with the averages, 5-minute average, 15-minute average, and so on, and the count. There's a producer request size, which gives the request size of the producer. There's the failed sends per second, which gives the number of failed sends per second, obviously. It also gives the value of the counts, the mean rate, the minute averages, and all of that. Serialization errors per second, right? Number of serialization errors occurring per second. That's another one that you're going to want to keep your eye on. Messages per second. This gives the number of messages produced per second from the producers. I want you to use the command that you see on your screen to monitor the consumer. This is just a consumer, but we can monitor any and all consumers. Max lag is going to tell us by how many messages the consumer is lagging behind the producer. Minimum fetch rate. This gives the minimum rate at which the consumer sends the fetch request to the broker. With the consumer dead, this value becomes close to 0. There's bytes per second, which is the number of bytes consumed per second. There's messages per second, which is obviously the number of messages consumed per second. There's fetch request rate and time in milliseconds, and this gives the values for the rate at which the consumer fetches the request and the latencies involved in that process. There's the fetch response size. It gives the fetch size for the consumer. It gives it in different formats. The fetch queue size, the queue size of the fetch request for the client ID, thread ID, and the topic requested. The Kafka commits per second, right? The fetch size for the Kafka commits per second, and all the different ways that it can be measured. The rebalance rate in time, which is the latency and rate of rebalancing for the consumer. That's another important one to keep your eye on. There's the zookeeper commits per second. And the zookeeper commits per second, it gives the fetch size of the zookeeper commits per second, and it gives it in all of the standard formats that you would expect. So here's my point. I just went over some of the kind of important metrics that you want to keep an eye on, but there's tens of thousands of attributes. These are some of the most important ones, and I'm going to talk about these in this section here. So a properly functioning Kafka cluster can handle a significant amount of data. So it's important that you monitor the health of your Kafka deployment to maintain a reliable performance from the applications that are going to depend on it. And these Kafka metrics, they can be broken down into roughly 3 categories. Kafka server metrics, primarily the broker, but that would include the node and the JVM with that. Producer metrics and consumer metrics. Because Kafka relies on Zookeeper to main state, it's also important to monitor Zookeeper. So what I want to do is I want to tell you the key metrics from the broker, the producer, and the consumer. That's what we're going to cover in the upcoming sections.